Okay, so now we're going to talk about the periodic table. The periodic table is arranged in groups, which are our columns, and they are also arranged in periods, which are our rows. A group number indicates the number of outer valence electrons that particular element has, where the period number tells you the number of energy levels occupied by the electron. So for example, sodium. It has a group number equal to 1 and a period number which is equal to 3. This information is helpful when we draw energy level diagrams, which is what we're going to talk about next. Energy level diagrams tells us when atoms are electrically neutral, which means that the number of protons is equal to the number of electrons. So the maximum number of electrons for the third level is 8, for the second level is 8, and for the first level is 2. So now we're going to look at some examples. So, for example, if something has 11 protons, it has to be sodium. Okay? So, because sodium has 11 protons, that means it must have 11 electrons. In the first energy level, there are 2 electrons which are used. So that means that we still have 9 more electrons. The second energy level has 8 electrons. There, 2 plus 8 is equal to 10, so that means we have 1 more electron, which will be found on the third energy level. If we compare that to something that has 3 protons, in this case is lithium. Lithium has 2 electrons, obviously, in its first energy level, but now it's only got 1 electron left, which is located in its second energy level. Next we talk about ions. So ions are particles or groups of particles that have a net charge, either positive or negative. Neutral atoms are unstable if their valence energy level is not full. So atoms will strive to satisfy the octet rule in order to become stable. So in other words, they strive to have a full valence level, and they do so by giving away or taking electrons. So we have 2 groups of elements on our periodic table. We have metals and we have nonmetals. Metals give away electrons and become positive ions, for example, we have Na+, Ca2+, and Fe3+, where nonmetals take electrons and become negative ions. For example, we have Cl-, P3-, and O2-. So examples. We have the sodium atom. The sodium atom is going to have 11 protons, okay? That's going to be standard. Alright? And that means that it is going to have 11 electrons. So we've got, again, 2 and 8 is 10, plus 1 is 11. Now let's compare that to the sodium ion. The sodium ion still has 11 protons. That's not going to change. And it is now, though, termed Na+. And the reason is that it's now given up that 1 electron. So it's got 2 electrons in its first energy level and 8 in its second. Let's do some more examples here. We've got the chlorine atom. Chlorine has 7 protons, and it is shown by capital C and lowercase l. Now, 17 protons means it must have 17 electrons. So in its first energy level, it's going to have 2 electrons. Second level is full at 8 electrons, so now we've got 10. That means we have 7 left, and those are located on the third energy level. Now if we compare that to the chloride ion, again it has 17 protons, but because it is now going to fill its octet rule, it is now Cl-. So we've got 2 electrons on its first energy level, 8 electrons on its second, and now that it's taken that additional electron here, we've got 8 on its third. So your assignment now is to, 1, draw argon and neon and compare them to Na+ and Cl-, and do pages 1 to 2 in your workbook. Have a great day.